I got, let me think, if I do it that way, you can see the perpendicular. Okay, here's a point called A, so if I make that big enough and I'm writing inside down, upside down, whatever. Point A, is that readable? It'll be more clear like that. There's A. Now, if I said I've got all these other points all over the place, so point there, point there, point there, point there, I want to get all those points, and I want to have no doubt in my mind that all those points lie in this plane that I'm holding in my hand. Ready? I could get that vector there, 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 that vector there, and that vector there, and I could keep going and get all those vectors. Where did it all start at? A. How would I go from A to that point there? Using vectors. I go from A back to where?
Origin.
Which is the minus of A. Plus I come back out to R. So I could get that vector there. I could get that vector there. So if you get that one there, I'd go minus back to A back to the origin, which is the minus of A. A minus of A. Yeah. Capital A for its position, A underscore for its vector. And I could go out to its new position. Say I could call that maybe R1 and R2, and I could underscore all of them and write all over them. So I can go from there to there. Okay. Now what happens if I get any vector anywhere, anytime, and I get which product? The dot product with the perpendicular.
Oh no.
So if I got rid of all these here, and I just had for example, that vector there. Ready? Now by the way, that vector there, if I didn't have that, I could spin around it. Can you see? Like, that's just a line. I can spin all around that. But the moment I do this here, I'm spinning around, I say I've got a perpendicular there. Does it fix that plane? There is only one plane and one only. So, if I go from point back to the origin and to any point, let's just call it now, just call it any point R. So on my plane, got a point called A, and I've got points everywhere called R. So I go from A back to the origin, so if I draw it up in 3 doing that origin, and I go back out to all of these points. Then I say to you, I've got a perpendicular, and I'm going to use N for well, everyone uses N, I don't use, the world uses N for perpendicular. I think of this perpendicular, I don't know, perpendicular. I don't know why people use N, but they use R for any point, they use A for a particular point, and that. What happens if I multiply a vector, or any vector, by its perpendicular? What do I get? Dot product, not cross product. 0. Now I can go minus A times N, that's another dot product. And I've got plus R dot N, dot product is 0. If I add A dot N to this side, I've got to add A dot N to that side, and I've got R dot N equals A dot N. And I call that N. By the way, it's written on your formula sheet here, so you don't have to memorise it, but you use it all the time. That's the equation of A vector given what? Let's write up what it is. It's the equation of a plane. I said equation of a plane given a point and a perpendicular. Oh, I should be fussy. A point in the plane and a perpendicular to the plane. That's what we're actually doing. Equation of a plane. Now we'll do an example and you'll suddenly go, I remember being at school and my teacher explaining stuff and I'd have no idea. And they'd put up an example and they go, that's all it is. Okay, with this bit here then, remember this is any vector. What's this one? The vector perpendicular. What's this one? A position vector. What's this one? The vector perpendicular. What happens when I multiply two vectors with a dot product?
They become scalar.
They become a scalar, which I could use any letter that's not underscored. So C for constant, most people will write C for constant. So that's the equation of a plane. So let's do one. You ready? I should get you to make up the numbers for me. Give me a point anywhere, somewhere. Ben, give me a point in 3D. Point called A.
1i, 2j and 7k.
1i, 2j and 7k. There's a point. Okay. We want a plane that includes that point, but it is perpendicular to, and I'll go Ethan. Pick me a perpendicular. It's not the same as that, otherwise it's just a point and it's, oh, that's an interesting thought. Not thought of it. Give me anything. You want to go negatives and go yucky, or do you want us to just stick to positives?
Just anything,
anywhere.
2y plus 5j. Take.
Oh.
No, okay, just go plus, sorry.
No, you can play, take. Oh, you do.
Plus 3.
Plus 3. Okay, so we should figure this out as a diagram for a moment. So I think I can get rid of that. You ready? So where is A? So can we model this thing through what it actually means? Get a diagram up, maybe use my trusty thingamajigamy. So we go to 1, we go to 2, we come out 7, we got a point. Can I do it? There's a point about there somewhere. There? I got a point there. Yeah? That's still recording. Now I've got a perpendicular, and the perpendicular is anywhere in space. You're right? Anywhere in space. That goes at 2, 5, 3. So I'm going to do a separate diagram for it. So this is at 2, 5, and 3. So we're at about here somewhere. So we've got one there. So we've got a point out here, and we've got a perpendicular to it that's, so let's try to get it. Can I get a point here? Oh, how can I do it? I can do it that way, can't I? Oh, it's a big fat point. What did I say? 1, 2, do you want all this or not? 1, 2, 7. I got a point about there somewhere. And I've got a perpendicular that is 2, 5, 3, which is about there. So that point perpendicular to that point there, perpendicular to 2, 5, 3, which is about, oh, I can't do it. Can I do it? There. And it locks it in place. So let's do the question. What's the formula? What's my stupid way to remember it? N. N stands for indicular. I'm going to write it this way. 2, 5, 3. 2, 5, 3. This one's the variable for R, saying any R anywhere on that plane. And A is 1, 2, 7. Dot product. What's the dot product of those? 2 plus 10 plus 21. So R dot 2, 5, 3 is that. So the equation of this plane, its unique equation, not just any equation anywhere, its absolute unique equation is R dot 2, 5, 3 is 33. And that one that I tried to represent in the diagram is that plane. Interesting. Give me a second, I've got to go a step further before I get to your question. What if I replace the R by X, Y, Z? Dot product, not cross product.
Yes.
So that means 2X plus 5Y plus 3Z is 33. And now that's the, what's it called? Cartesian equation.
That's a real doozy.
Of that plane M3D. So you've got the one that comes from Rn, which is that one. Like this one's obviously the Cartesian equation. So you walk in your next test, I give you that, and I say, get me the Cartesian equation. And you go, I don't know what to do. Rn. And turn the R into X, Y, and Z. does 2i plus 3j plus k lie on the plane? Perfect question. R dot 253 equals 33. Does that point lie on that plane? Wouldn't it be a fluke if I just fluked? Wouldn't it be incredible if I just fluked it?
That would be
Yeah,
wild.
talk about mine. So let's do it. 2, oh, hey, slow down, stop, I'm rushing. 2, 3, 1 times by 2, 5, 3. Does that equal 33? 4 plus 15 plus 3 does not equal 33. So does that point lie on the plane that we just determined, which is that one? And the answer is? No.